आज हम पढ़ाई करेंगे इंजन परफॉर्मेंस के बारे में। इसकी जानकारी हमारे इंजीनियरिंग स्टूडेंट के लिए बहुत ही आवश्यक है और इंजन परफॉर्मेंस इंटरनल कंबशन इंजन के लिए अति आवश्यक है। द इंजन परफॉर्मेंस इज इंडिकेटेड बाय द टर्म ऑफ द इंजन efficiency which is denoted by eta, and efficiency and engine performance are listed below, meaning that the in which quantity is required to find out for calculating the engine performance or knowing the performance of the engine, through which the quantities we can calculate it. हम सबसे पहले आते हैं इंडिकेटेड थर्मल इफिशिएंसी। इसको हम नेक्स्ट आगे पूरी तरह से डिस्क्राइब करेंगे। तो लिस्टेड परफॉर्मेंस आर इंडिकेटेड थर्मल इफिशिएंसी, ब्रेक थर्मल इफिशिएंसी, मैकेनिकल इफिशिएंसी, वॉल्यूमेरिक इफिशिएंसी, रिलेटिव इफिशिएंसी। इसको हम दूसरा नाम इफिशिएंसी रेशियो के भी नाम से जानते हैं। इसको डिनोटेड बाय ईटा रिलेटिव। देन मीन इफेक्टिव प्रेशर थ्रू विच द प्रेशर इज वर्किंग बाय द इंजन, दिस इज नोन एज द मीन इफेक्टिव प्रेशर। मीन पिस्टन स्पीड डिनोटेड बाय एस बार पी, सफिक्स पी। स्पेसिफिक पावर आउटपुट PS, स्पेसिफिक fuel consumption, इनलेट valve match index denoted by Z, air fuel ratio in other books written fuel air ratio, AYF or FIA, and the calorific value of fuel CV. I like diesel of the calorific value is 44,000 calories. अब हम पढ़ेंगे एनर्जी डिस्ट्रीब्यूशन। What is the energy distribution? The energy distribution from the bigger rectangular shows the total energy which is developed by the fuel of which is burned inside the engine cylinder. Therefore, which is denoted by E in reference size in kilowatt. Then the total energy in fuel in kilowatt. Total energy developed, middle rectangle shows the indicated power when the burning of the fuel inside of the cylinder. The total energy developed by the engine, this is known as the indicated power or in kilowatt. And total energy minus energy losses, I like exhaust losses, I like coolant losses, radiation losses, etc, etc. This type of the losses in fuel energy is equal to indicated power energy. Next is the close relation of the indicated power and brake power. When the indicated power is developed by the burning of the fuel inside of the cylinder, some frictional losses developed when rotating the or turning the shaft, i.e. when the engine is started, then the indicated power developed and making a torque for developing the electric power due to rotating the shaft of the turbine. Therefore, the frictional loss is developed. Then brake power, which is rotating the shaft, which is output is given from the shaft. This is known as the brake power. And brake thermal efficiency is equal to the indicated thermal efficiency minus losses due to the friction, i.e. brake power equal to indicated power minus losses due to friction. If we calculated the losses due to friction, then we written as indicated power minus brake power. Some calculations are here. The total energy E equal to Bp plus losses due to friction and losses due to coolant, exhaust and radiation etc. For closed relation, brake thermal efficiency equal to indicated power minus losses due to friction, and indicated thermal efficiency power, not in energy. Here efficiency is not energy. Then the indicated power equal to energy developed by the engine by burning of the fuel. Like a fuel is used, gasoline, diesel. First, the indicated thermal efficiency ITH, ETA-ITH, the ratio of the energy developed by the engine in the indicator diagram, which is known as the indicated power, to the calorific value of fuel. I like a gasoline engine of fuel, and this is petrol, LPG in use in domestic auto, and diesel which is used in car, heavy vehicles like buses, trucks, and this ratio is known as the indicated thermal efficiency, which is indicated by the ETA-ITH. ITH is the indicated thermal and ETA is the efficiency. Now the ratio is indicated power IP, which is in kilowatt or kilojoule per second. Joule per second is known as the watt, therefore kilowatt. And the energy of fuel is per second, kilojoule per second. In the above unit and below unit, this is the same unit. I like approximate unit in kilojoule per second, then below unit is also energy of fuel in kilojoule per second. Now the kilojoule per second, and we know that the value of the calorific value of fuel in kilojoule, but how much fuel is there, therefore kg per kg, therefore the calorific value we have taken in kilojoule per kg, therefore how much fuel is delivered for burning, then the mass of the fuel in which the per second, I is the in per second or per hour, how much fuel inside the engine burned. Therefore mass of the fuel per second, this kg per second, which is taken in the unit is kg per second, and the calorific value of fuel kilojoule per kg. Therefore cutting the kg cancellation, cancel both part. Therefore in the last unit is, which is in percentage, ETA-ITH equal to IP kilojoule per second divide mass into CV, which is also kilojoule per second, and which is written in percentage. Brake thermal efficiency denoted by the eta BTH, the ratio of the energy developed by the shaft which is rotating the prime mover of the like turbine shaft, then the output power developed by the engine. This is known as the brake power. This is the out power BP. Shaft power is also, second name is also known as the shaft power. To the input fuel energy, calorific value of the fuel, this is CB, is known as the brake thermal efficiency. Then brake power divide energy of the fuel per second is the fuel consumption is like. Therefore BP in kilojoule per second and mass of the fuel in kg per second and CB in kilojoule per kg. Therefore the ratio of the brake thermal efficiency eta BTH in percentage, and both the units in same unit as like kilowatt or kilojoule per second. Mechanical efficiency denoted by eta M. Mechanical efficiency is defined as the ratio of the brake power BP or the shaft power, which is delivered power by the shaft, to the indicated power, which is the power developed by the piston and engine cylinder. It is denoted by eta M, and eta M is the ratio of brake power to the indicated power. We know that the indicated power IP equal to BP plus frictional power FP, or we calculate the in any equation to solving the problem, frictional power FP equal to IP minus BP. Therefore, the mechanical efficiency eta M, which is brake power divided brake power plus frictional power, and this value is in percentage. Volumeric efficiency denoted by the eta V, suffix of small v. Then the volumeric efficiency is defined as the ratio of the volume flow rate of air into the intake system divided by the rate at which the volume is displaced by the system. Mass of the air eta V equal to divide rho A, this is the density of the air, B is the displaced volume, into N by 2, which is denoted in result shown in percentage, and here N by 2 is used for the 4-stroke engine. Therefore, in 4-stroke engine is that when the 2 revolution of the crankshaft, then only one power we get, only one power stroke. Therefore, the RPM is taken for the 4-stroke engine is N by 2. In alternatively, eta V is the volumeric efficiency equal to MA divided rho A into VD. Now the relative efficiency, this is the ratio of the efficiency ratio, i.e. the ratio of the thermal efficiency of an engine to an actual cycle efficiency of an engine. Thermal efficiency and actual note. This is the ideal efficiency of an engine, which is the air standard efficiency. Now the relative efficiency equal to actual thermal efficiency eta TH. Generally we have taken brake thermal efficiency and divided by the air standard efficiency eta ITH. Eta relative equal to actual thermal efficiency eta TH, and the air standard efficiency is equal to eta air, which is in percentage. Mean effective pressure, which is denoted by the PM or PMEP. Mean effective pressure is the average pressure inside of the cylinders of an internal combustion engine. PM equal to area of the indicator diagram to the length of the indicator diagram. For finding the mean effective pressure, first find out the formula of the indicated power. IP equal to PIM LANK divide 60 into 10 to the power whole cube. Therefore, PIM, this is the indicated mean effective pressure, equal to 60 into 10 to the cube into IP divide LANK, and corresponding to the brake mean effective pressure, which is calculated by the brake power. PIM is the indicated mean effective pressure, and BP is the brake mean effective pressure, which is measured in Newton per meter square, is equal to the Pascal, and IP in kilowatt, brake power BP in kilowatt, L is the length of the stroke, which is in measured in meter. A is the area of the piston, which is meter square. Capital N, which is the revolution per minute, the speed of the rotating shaft or crankshaft. Small n, which is the number of the power stroke for n by 2 for the 4-stroke engines, and the n is the 2-stroke engine, and k is the number of cylinders. Mean piston speed S bar and S suffix p. Therefore, S suffix p equal to 2 into length of the stroke into n is the revolution per minute, which is meter per second. The rotational speed n is taken in RPM, revolution per minute, and we consider in automobile engines where the higher speed of the engine is taken, mean piston speed is 15 and the lower speed is 8. Now the 8 number specific power output. The power output per unit piston area. This is known as the specific power output, which is the power output BP, which is the brake power divided area. Then the specific power output PS equal to constant into brake mean effective pressure into mean piston speed. Specific fuel consumption SFC, it is the ratio of the fuel consumption per unit time to the power, either indicated power or brake power. SFC is measured in kg per kilowatt hour. For brake specific fuel consumption per unit time divide brake power, kilogram per kilowatt hour, and ISFC indicated specific fuel consumption per unit time divided indicated power, it is measured in kg per kilowatt hour. For finding the inlet valve match index Z, where the first find out the gas velocity U, which is the AP, divide CI AI into VP. Therefore, U is the gas velocity through the inlet valve smallest flow area meter per second. AP is the piston area. A is the nominal intake valve operating area, also measured in meter square, and Ci is the inlet valve flow coefficient. Therefore, we divide the gas velocity U divide alpha. Now, the putting the value of the U, AP into VP divide Ci AI, and then the AP equal to pi by 4 d square. Here the d square is B and the AI d square is di. Therefore, B by di whole square into VP divide Ci into alpha. This is value is the Z, which is the inlet valve match index. Inlet valve match index Z equal to B by di whole square into Vp divide Ci into alpha. The abbreviations are B equal to cylinder diameter, di equal to inlet valve diameter, Vp equal to mean piston speed, alpha equal to inlet sonic velocity, Ci equal to inlet valve average flow coefficient, Z equal to inlet valve match index. When match index is increases, which is plotted in x-axis, and eta velocity in y-axis. When the match index Z is increases, then the volumetric efficiency eta V equal to D is decreases. At Z equal to 0.55, therefore the maximum volumetric efficiency is 0.88. Fuel air ratio or air fuel ratio abbreviation is F by A or A by F. It is the ratio of the mass of fuel to the mass of the air or vice versa. It is generally used in A by F, air fuel ratio, in SI engine, because the SI engine is the fuel fuel air ratio mixture is given inside the cylinder, whereas the compression ignition engine CI engine is only air is received from the intake valve. Therefore, the compression ignition engine only accelerating the fuel due to deriving or increasing the power. Here the equivalent ratio phi is denoted by equivalent ratio. Here equivalent ratio is the actual air ratio, fuel air ratio divided stoichiometric fuel air ratio. What is stoichiometric fuel ratio? Where the fuel is completely burned with the mixture of the air. I like phi equal to 1, it means that this is the fuel is completely burned by the intake volume of air. This is known as the stoichiometric ratio. If the phi is less than 1, this means the air is more than the fuel and it is not complete the mixture, and the air in this the ratio is the air is more than the fuel inserted. Phi is greater than 1, then the rich mixture, where the sufficient air is not supplied to the mixture of the fuel. Therefore, this is the rich mixture, which is value is more than the mixture of the stoichiometric fuel air ratio. Calorific value of fuel, which is denoted by the CV, which is very important parameter for the engines, and this value is carried out the total power through which the engine will work. Now the calorific value of the fuel is the thermal energy released per unit quantity of fuel when the fuel is burned completely. It is measured in kilojoule per kg, for which in 1 kg of the fuel in how much kilojoule calorie is given, or in 1 kg of fuel is how much energy is released when burned the fuel is completely. Thank you.